and you should see some text saying AMD Instinct Mi60 performance test. That's exactly what we're going to be doing today. I should add that this is going to be for image generation. So I want this tutorial to be more fun, and also you guys can obviously post any questions. It's more of an ask me anything. So I'll be able to to honor your requests. And also be sure to subscribe, like, and follow, and leave comments, because that helps the channel grow. And what happens is when the channel grows, there will be more viewers and obviously more subscribers, but the more important thing is the more people who join, the algorithm sends it out to more viewers. So what that means is that if they come and share the information, whether it's in the live chat or they contact me personally, I'll be able to share. So for example, a few things we're doing today, actually two things I'm going to show you today, were actually taught to me literally in what some of them were taught in a live stream. Another one, a subscriber or a viewer actually emailed me and sent me over the information. So now for the second part, the viewer, the information had come to it on my own, so it's still pretty good. So I'm saying I'm going to share all that information with you today. So be sure to subscribe and like it. It really helps the channel out a lot. Thanks, guys. All right, back to the tutorial. So I'm also live streaming on YouTube, BitChute, Rumble, and Odyssey. So you can feel free to join the live chat there. As I said, this is a fun, the night streams are more relaxed because I don't have to rush and go look after the chickens or finish up the shed build or anything like that. It's just fun. It's a fun time, meaning that I can stay up later, etc., etc. All right. So this is what we did earlier today. I reinstalled ComfyUI with a ROCm 6.4 for unsupported AMD Instinct Mi60 GPU. So if you guys don't know, a quick backstory, I bought this GPU in the summer of this year, so that's about 3 months ago or so, probably even less. So I bought it, and that was one of the showcases for my workstation build. I used to have an Intel i7 2600 from 2011. It was time to upgrade, so I did upgrade, and this is the dedicated GPU which I have. I also have an integrated GPU that's for the daily driver. So the problem with this GPU is that it's a server GPU. It was for crypto mining. So the problem is it didn't come with a cooling system. So what I did was I purchased a 3D printed fan shroud with a 40mm fan, and just the fan just blows air right through it. So that's how it cools down. So when I'm doing AI stuff, I've noticed that not for images, but for like video or when it's chat, the temperature goes up really fast. So I don't think a fan profile is gonna work. So what I do is I just control it manually, because I'm always gonna be here and generating, so or I'll be around, so it's fine. I can leave it on for a while and then switch it off. So I prefer manually. It's fine. I don't mind it. For example, if you guys saw the earlier live stream I did, you could see when it was using the GPU for image generation, the temperature of the CPU goes up to 80. So that means that the fan profile can't even keep up. That's what I'm saying. I prefer manually because I can tune it. Unfortunately, for this particular one, the BIOS doesn't show the GPU temperatures. I mean, there's ways you can do it. You can jimmy something up, but it's fine. It works perfectly fine. I have created a tutorial explaining that, so I don't want to spend too much talking about that here, because there's a dedicated tutorial explaining how I resolved all those issues. So this is my system. It's Fedora 43. Now I recently upgraded to Fedora 43. The reason I did that is because I wanted to use Llama CPP. I wanted to use the Python binding. And Fedora 42 has llama.cpp, but that one doesn't have the Python binding. So I wanted the Python binding, which only came in Fedora 43. A problem with that is Fedora 42 came with ROCm 6.3, which supports the GPU. So that's the last supported version that AMD officially supported. In 6.4, it's not supported. However, what AMD did is they just removed the tensor files. So if you can find like another version like 6.3, grab those tensor files and just put them in this proper place, and then you'll be good to go again. So I don't need to do that because Fedora automatically does that for me. Now in 7 you do the same thing, and I'll show you that pretty soon. And then in from what I can tell, in 7.1 AMD actually went and removed the detection for this particular GPU. So the good news is Fedora has committed to, in the next version, to support this GPU. So I'm guessing they're going to revert that Git commit. So so this GPU will still be good for, who knows, probably another 1 or 2 years. And so you can compile yourself or order or get another version. So you'll be fine. Is this GPU still worth it? Yes. Now be careful. If you go purchase this now, you're probably going to pay more than I paid. I thought I paid a little bit too much in summer, so the price has gone up because the GPUs are popular, which is really unfortunate. But just look out for some deals, especially if the AI bubble crashes. There will be a lot of GPUs, memory, and stuff. So just be aware of that. Just hold. I mean, if you can wait, hold on. I waited. Remember, I said my system was from 2011, so I waited. What is that? Wait, 14 years. So as long as the system is decent, you can wait. Okay. So I'm not going to show you the steps for reinstalling ComfyUI because that's what we did in the earlier tutorial. The part we're going to do is I want to start right here. So this part is very important, is that I put this in my bash rc file. You have to do this overrides if you're installing an unsupported release. What happens is, for example, ComfyUI, it will detect that ROCm 6.4 is on the system, but that one doesn't have the, when it installs the wheel, in Python wheel, it won't be able to detect your particular GPU. So what you need to do is you need to override, and then you need, remember I said you have to copy the tensor files over, and I explained that in the earlier tutorial. Another thing you can also use to speed up, this made a significant, I tested this, Mi open, you get like 30 times the performance, so increase. Probably even more if, for example, if you're doing videos and stuff, it's going to be even more. I got up to 40% from some videos. So, but the problem I don't like about this is the first time you run something, it's gonna be slow. It might be slow up to 2 to 3 minutes, but then after that it will be faster. But the problem is it's only based on those specific parameters used. For example, usually when you're, for example, creating a video, even an image, the first one is a trial run. So let's say I want to make a video. I'm not going to make the video like 1080p. I'm going to make the video probably 216 by 216, very, very small. The reason for is for speed, and I want to see if the quality is anywhere decent. So if the quality is decent, then I'll bump it up to, say, HD, which is 720p, then higher. Now the problem is this Mi open at 216 by 216, it will pick the best algorithm. But then when you change even just 384 by 384, it's going to have to choose a different algorithm. So it's going to run this again. But that's not even the worst part. The worst part is it uses a SQLite database, and the SQLite database doesn't have a concurrency. So what that means is that because it runs in parallel, there's going to be some problems. Instead of locking up, like say a MySQL or MariaDB does, it will just crash. And that's annoying because you've only been waiting for 2-3 minutes. Now you're gonna start all over again. And the problem is, even if you stop ComfyUI, those parallel processes, they're still running in the background. So that's another. That's why I commented it out, because the reason I reinstalled ComfyUI was I wanted to play around with the videos again, and I was having issues with stable-diffusion.cpp. However, those issues have been resolved in the latest version. So does that mean I no longer need ComfyUI? Not really. I said it's just a way to, I wanted to show you guys, like, because ComfyUI also has some really good optimizations. So I wanted to show you that you can, because stable diffusion stable-diffusion.cpp is inspired by ComfyUI, even the models and all that stuff. So if you can get ComfyUI running, you can find, and then you should expect a significant speed improvement if you use stable-diffusion.cpp. So that's why I wanted to fool around with the videos and see how it works now. And so obviously as you go, it's very simple to create videos using obviously ComfyUI, but I said this tutorial is about speed. I want the speed. So obviously ROCm works, and I explain all this here, why these variables are very, very important, including the MIOpen. So MIOpen, again, it's the AMD's deep learning library. It searches for the best convolution algorithm, setting it to set to 4, forces MIOpen to always search for and apply the best algorithm. So it's better maybe to set to 3. 3 means that if there's one it used previously, that's one it's going to use. So I would recommend set it to 3 instead of 4. Even when version changes. So that's why I don't use 4. And then obviously you can put 0, meaning don't use it, and this is the path to the performance database. So as I said, it uses a what do you call it? It uses a SQLite. So it's recommended. Obviously, I have a SSD here, so it's fast enough, but looks like it can't keep up with the parallel, and that's a problem with SQLite. The database. Also, as we can see here, so I'm not going to do any video today. I mean, unless you guys request it, but the focus is just to show you the speed differences between the the same model, but quantized. Okay, so as you can see, my system, it's an AMD Ryzen 5 5300 GT, 6 cores, 12 threads. 32 gigs of DDR4 RAM. But usable is probably around 21-22 because it's the integrated graphics reserves 4 gigs of this, so we're down to 28. And I think about 4 gigs is also used by the system for something called GRAM. It's like a cache, if you will. So disk cache. So then we're down. So we're down again, and obviously there's stuff opening like OBS, this browser windows, and if you're running out applications, right? So you need some RAM for that as well. So really, let's say it's probably around 21.8 usable RAM. So so that means that obviously if you're loading models, you have to be careful because I don't really have 32 now. I can also put the disk cache, but that's going to slow it down. So what's the point, right? And then obviously the GPU is AMD Instinct Mi60. That's 32 gigs of HBM2 VRAM. Operating system, as I said before, is Linux Fedora. Workstation 43. That means it's a GNOME desktop. I'm using Wayland, GNOME 49. So I downloaded it's Checkpoint. It's the v15-pruned-imonly fp16.save tensors. So this was specific to ComfyUI, but this can also be used in stable-diffusion.cpp. Okay, and as you can see, I did generate some images with ComfyUI, and yeah, so no problem at all. They're 512 by 512, as you can see down here. You see the problem even in this screenshot. It says MIOpen error. See, this is the problem. It's because when it's finding the when it's trying to find the best algorithm, what it does is it will crash no, it's not. So when I said finding, when it runs through some it forms some quick algorithms performance to see which one is the best. You see, it will always crash. That's the problem here. Maybe the SSD is not fast enough, I don't know, but yeah, it runs parallel connections as a problem. But when it does work, you can see the difference here: 10 seconds down to 6 seconds. See, then it becomes 6 seconds, right? And obviously it can also go faster, but I'm pretty happy with 6 seconds to generate an image, right? So, and that's 20 steps, so that's pretty good. Let's be honest, that's pretty good. So I'm going to show you how to get something similar to this without using mi open, and we're gonna get started. So as you can see here, this was the video for this article, and then this one that I'm doing right now, this live stream, is right here, similar to this. And as you can tell, this is also live, and we're gonna stop right here, right there. Okay, right there. Now let's go through the links quickly. This one I've explained before. It's by wasd-tech. So this one is the viewer who actually contacted me and let me know that they also created an article on how to run ROCm on a unsupported GPU. So so it also in DistroBox, and the same thing I did. So if you look, it's in Italian, but it's pretty easy to follow along. You don't even need to translate it. You just follow the instructions. But if it's pretty easy to translate. Like for example, like I don't speak Italian or Italian, but I can easily tell, like Llama CPP. That's clearly I talked about that. I haven't tried this one yet, Cobalt CPP. I haven't tried VLLM yet. Stable-diffusion, Web UI, ComfyUI, SwarmUI, 1.2GP. So this person obviously went through a lot here to explain how to do all this stuff, and they say you can just follow the instructions. Ironic enough, Fedora Linux, interesting. DistroBox, and you saw my DistroBox tutorial, and obviously this is a Debian. No, this is actually Fedora. You can see DNF upgrade and all that stuff. That's mine. You see here. So you can create DistroBox. Either you can choose ROCm 7.0 or you can pick 6.4. So I said 6.4 is the one that comes with Fedora 43. That's the one I used. And yeah, so you enter, you get the Alma Linux what do you call it, ROC, and then you can see here, you see this, they also have their what do you call this, the environmental variables. And now for the distro box, you see there's more what do you call them, some more variables if you're for compiling things. Yeah, so I said it's pretty easy to follow along. You can just take a look. It's a pretty long article because it does obviously both of them, 7.02 and 6.444. So I've been putting the link for this one in the articles. Sorry, not in the article, in the live streams. You know what? I'm going to do that again just to do this as well. So I'll copy this and I'll paste it in the. Right, so I've pasted it. That's what you're hearing right now is BitChute. I don't know. I don't know what's wrong with BitChute. Okay, I put it in BitChute. I'm gonna put it in. I put it in the. What's this one? I put it in the Rumble. I have to refresh Rumble, make sure it's working. Yes, it is. So it's in the Rumble live chat, and I'm gonna paste it also in the Odyssey live chat. Let me see, Odyssey. Yes, Odyssey is working, so it's there. And obviously, I'm gonna put it in YouTube as well. So this is gonna be for AMD. What is it? AMD ROCm guide by WASD. Okay, I put it in YouTube as well if you're following along, and there you go. All right, so I found this today. This is the Instinct maybe not today, maybe yesterday. Mi60 drivers and downloads, latest version. So what I'm interested in is the specs. So this AMD Instinct Mi60, you see it's part of the Instinct family. It's for servers. It was actually almost, what is that, 6 is that 6 years ago? 7 years ago? Almost 7 years ago, right? Yeah, almost 7 years ago. So this is, oh no, it's actually more than 7 years ago. Sorry, my bad. Yeah, this is more than 7 years ago. Because today is the 20th at time of this recording, so this was, yeah, so this is more than 7 years ago. This GPU was released. You see it's a Vega 20, and what else is here? So the one we're interested in is right here. So as you can tell, the peak half precision, actually let's go to the single precision. Single precision has FP32. That means that if you have a model that's FP32, this guy, this GPU will like that very much. I'll come back to this later. Oh, it also even does FP64. I haven't come across any FP64 models yet, but yeah, this does support it. Now, if you notice something interesting, you go from FP, which is double precision, and floating point, that's what the FP stands for, and then 32 is single precision, and then the half precision FP16. If you notice something interesting, you see they double, right? So it gets faster and faster. Now, a lot of newer GPUs, they also have FP8. There are a lot of models which are FP8. So the problem with this particular GPU is that if it runs any FP8 models, it's going to be slower. If you remember when people were trying to help me when I first started using stuff like ComfyUI, when I did that, it was actually even slower, right? This is why. Now I understand why. I didn't understand then, but now I do. So because obviously it's not a GPU, it doesn't support FP8. So, but if you notice down here, it does say int 8. And better than that, look at that. So it's double the FP16 performance. So that means that if I do something that doesn't have floating point, if you don't know what floating points are, that means decimals. Anything that does or has less decimals, it's going to be flying. It's double the speed. Look at that. It's exactly double the speed. Exactly double the speed. So what this means is that I should stick to, for example, stuff like Q8. That's why this tutorial is here today. Q8 will blow away this one, so go much faster, it'll be double the speed. Now you might be thinking, hey, if int 8 is 59 tops here, what happens if you have int 4? You know, like Q4. What's going to happen there? Well, here's the thing. Q4 is actually going to be slower than this one. However, it will still be fast enough that it's worth it to use it instead of using, for example, FP16, FP32, and FP64. And that's what we're going to test today, and just to prove it. Now, obviously, you also have to be careful, because after you got away from Q8 here, int 8, you probably start seeing some degradation and some artifacts, especially images are probably not too much of a problem, because usually images are meant to fool the human eye, so you can probably get away with that. However, when it's something like chat, whatever, the results are definitely going to suffer. So we're going to test this as well. And if you want to know more about this GPU, you can see here it's 200 watts peak, and yeah, so as I said, 32 gigs, HBM2, and etc here. I don't think there's anything else. Yeah, so it also supports Vulkan 1.0, ROCm, OpenCL, and OpenGL as well. Unfortunately for Blender removed the OpenCL, it wasn't supported very well. They're working towards getting Vulkan, so that will be actually pretty good. I have a Vulkan, what do you call it? I do have Vulkan installed on the system, and I tested with Stable Diffusion. It's actually really stable-diffusion.cpp. It's actually pretty fast, especially for loading models. Then it always, there's a little hiccup. I think it's hard-coded somewhere. I don't know if it's a Python thing or some other library where it's only hard-coded to use, or system only 4 gigs, which is annoying because you see here it says 32 gigs. Anyway, so this is it. Now the good news, as I said before, is Fedora. You see fedoraproject.org, as I said before, I was running Fedora 42 until just very recently, and you see Fedora 42 supports the GPU, this one here, GFX 906. Now, and Fedora 43, or if you're also using the Enterprise Linux here, 10.1, the Red Hat one, you notice it's here as well, GFX 906. So that was surprising. What I'm saying is that they don't explain it, but I said you can still use it if you use your if you put something in your batch RC. So I'll show you how to do that as well. And then the interesting thing about that is we go to Fedora 44, which will come out in spring, and it's it. My GPU is still there. However, I found something pretty interesting about this. I believe very recently in Rawhide, that's the testing bed for the next versions of Fedora, it has ROCm 6.4, so I think they're gonna continue doing that support. That's amazing. So meaning that this GPU, as I said, I'm gonna keep it for a while because it's gonna still be supported by Fedora. I just need to put the that hack, which I'll show you in a second. So the interesting thing about all this is it says here packages, obviously in Fedora, this Fedora 44, I think, yeah, this will be in Fedora 44. See, the composable kernels, these are with GPUs with limited support. As you can see here, none of my my GPU is not anywhere here. So I'll get full support. Clap again for Fedora. I'm happy with that. So I'll show you that later if I do remember. So actually, maybe I should show you right now. I know. Let me show you right now because it's kind of related. So let's go right here. So if I go Fedora packages and I just type ROCm, so I want to go here and I'll show you. I'll go to builds. So this is what I was trying to tell you guys. You see that right now, actually pretty recently, sometime this week, as you can see, ROCm 7.1 landed in Fedora 44. And you can see I'm using Fedora 43. You see it's 6.4441. That landed obviously last month. And so this is great news. And then 7.01 is also in Fedora 44. So it looks like by the time spring comes around, I'll be making the, if I do upgrade to Fedora 44, I'll be jumping from 6.44, not to 7.1, I mean, so not to 7.01, but to 7.1. So that's really fantastic news. Okay, so this is ComfyUI. If you have never heard of ComfyUI, it's a very popular web UI for stable diffusion. Stable diffusion means that you can create, it's open source, so you can create obviously images, and you can create videos and animations and so many different other things. So now you see you can install here for Windows or for Mac, or you can go to GitHub. So we're going to go to GitHub. I believe this is a GitHub page, if I'm right. Yes, this is the GitHub page. So as you can see, this is the latest version 2 days ago, and the earlier tutorial I did upgrade to 0.3.7.0. So if you want to know how to perform upgrades, do that as well. It's the same thing as installing, so I showed you how to do that. And you can see there's some fixes. You can go read all of this, but that's fine. Even added some API nodes, add new Gemini nodes, so that's nice. And they fixed the Hang 3D 2.0. Okay, that's even better. All right, and then if you guys noticed, I tried to use my I used stable-diffusion.cpp to convert the images from so to convert that model from FP16 to Q8 and Q4. So when I tried, it didn't work. So I was thinking, okay, I probably need a custom node, which I was correct about. So what I did is I found this application. If you don't want to use stable-diffusion.cpp, this application is called HQQ. It's actually, it looks like it was made by what do you call it? Maintained by Dropbox. So this one is a fast and accurate model quantizer that skips the need for collaboration data. Quantize the largest models without collaboration data in just a few minutes at most. So the reason I haven't installed this yet is because it uses obviously Python, and I don't know how big this is going to be, because I've noticed this when you're working with AI stuff, the Python stuff gets really big really fast. But yeah, so here we go. This is basic usage, how to use it. So yeah, so there we go. If you're interested in this one, I can you can see it says here you can use it with custom quantization. That's what I wanted to do. For example, like Q4, Q3s, for VLM, LLM, perf training, and a few examples here as well. So I'm going to copy this one as well because I just heard about this today. So I'll paste this one as well. This is what do you call this one again? Half quart. Okay, I'll just copy this and just paste. I'll paste the link in there. And the link is here, so I'll just put it inside the chats as well. Copy all of that. Control-C to copy. So it's in YouTube, Odyssey, and I'm gonna paste it also in Rumble and I'll paste it in BitChute. Okay. All right. And then we can go here. So for ComfyUI, I found this ComfyUI-GGUF. This is the one to. So as you can see here, it provides support for files stored in the GGUF format, popularized by lambda.cpp. And then when quantization wasn't feasible for the regular unit models, convert to the transformer DIT models such as Flux systems affected by quantization. This allows the tuning to much lower bits per weight for variable bit rate quants on low-end GPUs. For further VRAM settings, a node to load the quantized version of the T5 text encoder is also included. So this is fantastic. So it comes with a VAE text encoder and obviously the model as well. And I'll show you that. I took some screenshots. So yeah, so basically all I did was I cloned it, and then I did pipe install, and then I was able to start using it. So I'll show you screenshots of this. I also have this one as well. It did find this one right away. Yeah, I found the text encoder because I said I did that for the Now, unfortunately, I still needed a VAE, and the only one I had was for the video. So clearly, I'm not going to use that one. So it was kind of pointless. I think I'll just stick with VP16. So it looks like ComfyUI is not very it's not very good for that. Maybe there's some custom nodes that do that, but I found it was too much of a hassle. So that's why this tutorial I mentioned stable-diffusion.cpp, which I believe is this one here, stable-diffusion.cpp. So this is by Leadjet. So this is pretty simple. You see, you just compile it, and then you just run the command. For example, I'll show you a command right here. You see, you just run this command with the with whatever version you have quantized, and that's it. And then boom, see, much faster than it's obviously faster than ComfyUI, and that's what we're going to test today. All right, so that's it. Let me pull up some screenshots I took. I'm not gonna bother. Oh, should I load up ComfyUI? Yeah, okay, I'll load up ComfyUI because I did promise to do that. So if I'm gonna promise something, I might as well do it. Okay, so I'm in this folder here. So I'll go cd ComfyUI, and this is the ROCm what do you call it, virtual environment. That's the one I was created. It's basically, I should actually call it ComfyUI because that's what it's for. So we'll go back one, and we go ROCm, and then bin/activate. Okay, then just type Python name, and you can see it's gonna load. So we can check here to see if it loaded my GPU properly, which it should. I found my GPU. I'm going to take a sip of water here. And zoom out just a little bit so I can show you what's going on. So you can tell VRAM is 32 gigs and total RAM is 27. I said this is not quite true, but it's actually less than this. So this is GFX 906, ROCm 6.4, and you can see CUDA 0. So the problem is a lot of these Python libraries, they expect CUDA. So the only way to get your AMD card running is if it thinks, no, it doesn't think it's CUDA. It just there's no option for another type of device unless it's the CPU. So it just calls it CUDA. Yeah. So yeah. So all right, and then I can see the pin memory. That's perfectly fine, and that's it. So it's running now. If I want to see this, I just need to go to where was that? Oh, it's down here. Localhost colon 8180. That's the default one. So as you can see here, I have I installed the custom nodes. I showed you there. So there's this one, ComfyUI -GGUF, and I'll show you what that looks like. So I'm gonna pull up a web browser here just to show you what it looks like. So 8188 localhost. You see, I already opened them here. So by default, the default image one. Gonna see. Oh, I forgot. I have this guy to navigate. Yeah, so this guy here. So you can see the default one here. This load model. It loads a checkpoint. Then there's a model there. There's a clip and the VAE. The problem is, you see, I did get the GGUF here, and you can see I can use different ones. I moved the folder again, but this is the one I last selected. I moved it because I can't use this in ComfyUI. And the clip, you see it found my quantized one, which is the Q5. I created this also in stable-diffusion.cpp. So that's fine, it did find it. And then see, the problem here with the VAE is I only have, I said I have this video one. That's the only one I have. I have this video one. So obviously I don't want to use that one because that's not for simple image generation. So that is a hold up. That's why I'm not able to generate images, because it will not be fair as well. I should get an image one specifically. I should get a 1.5 standard diffusion one to give it a fair test. So then I decided, no, instead of testing it like this, what I'm going to do is I'm going to test it in a different way. I'm going to use stable-diffusion. So that's where we can test it, because that's a much fairer test. Is things are equal is what I'm getting at. So we don't need this anymore. However, I want to just in case, just in case. So I can close this down. It's not needed. Okay, so it's finished. I actually just deactivate this one here, deactivate, and get out of here. I'm gonna set up my cooler application. So yeah, you know it's ready when it shows you 11987. So that's why I'm gonna go here. Just type 11987, and let me zoom out just a little. There we go. A little bit more. Come on. Can't zoom out anymore. Okay. Oh, I guess that must be 100%. Okay. That's fine. So you don't need to know any of this stuff. The most important thing is this one is the GPU. Right now it's at 43 degrees Celsius, so we don't need the integrated one or the Wi-Fi card. So I'm using this one, System Fan 2. I will set it up to 50%, and then I hit apply. It's kind of loud, so that's why I said I control it manually. Right now it's at 2%, which is just under 29,000, 2900 RPM, so 2900 RPM, so that's fine. All right, so we actually don't need this. Believe it or not, we actually don't need this. So I'm going to put you here. I'll put it on this side, so you can see the. Let me zoom in a little bit. So you can see the GPU temperature. This one here. This one we're going to pay to, but there's really no need to. So what I'm going to do is when you go to stable-diffusion, you can get the you can download the binary, The binary, the programmer, the author, the application author, said that he had problems with the ROCm, so the pre-compiled binary, he doesn't compile it with ROCm. So meaning that it's going to be slow. It's just going to use the CPU. It's good enough, but you know, I got the GPU for a reason. I want to use it. So what I did is I just cloned the I cloned the stable-diffusion.cpp, and let's actually go there again. I believe, if my math is correct, that it should be the latest version. Let's see what version. There might be a so yeah, yesterday. So I already have this one. I did this one, I believe. If I go to, I'll show you here. So let's go cd stable-diffusion.cpp. If I type git log, it says 3715498cc0. So that's the one. I did this one just yesterday. You can see the time. It's almost exactly 24 hours ago, and I did the cc. Added 2.1 image to video 1.3. Oh, image to video was added. I thought that was already there before. Interesting. So that feature was added. Okay, so that makes sense why I was able to produce videos yesterday. I guess there must have been some more bug fixes. Okay, that's fantastic. You guys are treated for a bonus. So then you just go to the, oops, I need to quit this. I go to the build folder, this one here, and you can see I did a whole bunch of tests, right? I tested a whole bunch of stuff. So and you see I was able to produce some videos. I think some of these videos might be older, but I was able to produce anything that says WAN. Remember before I was having problems with the WAN, the update. You see I'm able to produce some WAN stuff here. You see this one, and this one. I think this is one of the best ones I did. Yeah, you can see, very nice. And that's the 1.3 model. And this one is a weird one here. This is the Quint 5. It's a little bit weird, but yeah. And then there was some really, I was trying to speed things up, so I got some really wonky results as well. So I was getting that, and I remember that in ComfyUI, that's why I installed ComfyUI, is that for the WAN models, I think there's a math bug, because for example, if you want like 2 seconds and you say 12 frames per second, you can't put 24. If you put 24, you only get 1 second. You have to put like 25. You have to put an extra frame. So I remember that. Then that's why I was able to do this pretty very well. Now, obviously, you can also use the video model just to output one image. For example, like this one here, right? So yeah, so it does a pretty good. And this one's none of this worked, and I said that was the one when I was having some issues with the what do you call it, with another version. So this one is working pretty well. So as you can see here, you guys might remember this from my tutorial. I also I got different results. For example, this one is FP16. I think this is also Q8. We'll do all the results. You'll see them in a second. And then this white shoes. Funny enough, the smaller model was able to actually get exactly one, because I didn't actually want somebody's feet in here. So it came out pretty well. But I'm saying we'll do a review of the of this as well, so you can see it came out not too shabby. Not too shabby at all. There's obviously a few little artifacts, but I said for images, you most likely, unless you look with a fine-tooth comb, you won't be able to see them. So with that said, let's start our tests here. So in order to be fair or unfair, I'm just going to run the test once, because I already ran it before. So I'll show you what I did. Let me clear this. So I have to go back to I want to show you the ComfyUI folder, and I'll show you what I did. So what I did is I went to models, and oops, wrong one. It's ComfyUI. Go to the models folder. models, and was checkpoints here, checkpoints. As you can see, so this one, I downloaded this one from Hugging Face, and then what I did was I used Stable Diffusion to convert it into this one here, Q5, Q8, and then remember Q8 is supported on our on this GPU, and then I also made a smaller one, basically Q4 K. So when I did this, I was testing them, and the results were actually very surprising. So instead of me talking, let me actually show you. So I will. And obviously, the instructions from stable-diffusion.cpp, they're for Windows. You can tell because it uses the backslash. Linux uses the /. So I just had to change that, and obviously there's no exe on Linux. So let's go here, and I'll show you what I did was I where is it here? All right. Oh no, I don't want video. Do not want video. Yeah. So to do conversions, I'll show you the command I ran, for example, for this Q4. Yeah. Let me show you. So first thing you do is you just type bin/sd then --help. And let's zoom out just a little bit so I can show you some of the settings. So if we go here, you can see the schedulers. It obviously doesn't have as many schedulers as, for example, ComfyUI. And that's the schedulers, and there's also samplers. You see sampling methods. It's limited compared to obviously ComfyUI as well, even though it's inspired by ComfyUI. So then you see we have the convert. So to convert, it's -m here, and then you have to pick the type. You see the types. You can do Q5, from F32 all the way to Q4. Oh, there's an F32. I wonder if I should do that one. You know what? I'm gonna do the F32 as well. You know what? So because I'm gonna convert. So we can also convert a Q2. Oh, you know what? Let's do that. Let's do one Q2, and then we'll do an F32 as well. I'm gonna create one F32, and then I'm gonna create one Q2 just so that we can see if there's any quality improvements or loss as well. So with that said, I'm gonna put this in a specific folder so that things are not so it'll be easier to see what we're doing. So I'll do it in the command line here. Let me clear this. So I'm gonna call this make your tests. Actually, you know what? I won't do that. I'll just come up with a name. So the first thing I'm going to do is I'm going to go to the checkpoints here, and you see we have the FP16. So I'm going to create one FP32 right here as well. So we can see it's 2.1 gigs, and the Q4 is 1.7. So I think it will probably be 2.5. It may even be 3 gigs because it's double. Okay, so where's the conversion? Okay, here we go. Paste this. Oops. Okay, I'm using the full path, but I don't really need to. I'm using the full path. You can just put bin./d. That's fine. So convert. You see here convert, and then the model we want to convert is this one. You see this FP60. That's the one I downloaded. And then what I want to do is I want to make it I'm going to make it, what did I say? FP32, I'll just say .gguf. And then the type, you have to put -type. I think it was FP32, like that. I think that's what it is, floating point 32. So let's run that. Looks like I made a mistake. I suspect that I'll make a mistake. Let's go back. Where's the convert? Looks like I missed it. I went too fast. Where's sampling? Some more. Why can I see it? That's a model. Am I crazy? Why don't I see them? Width and height. Where's the M? Oh, I can't see it anymore. Am I crazy? What's going on? Come on. You guys are probably watching this laughing at me. I can't see it. Oh, here it is, M. So M, the type is, oh, it's just F32. It's just, oh, it's F32. Okay, there's no P. Okay, that's fine. So there's no P. It's just F32. So you see, it's done. It's done, and it's right here. You see, it's F32. The size is, oops, it says 0. What happened there? Oh, it's not finished yet. Oops, I thought it was done. Now it's finished. You see, it's 4.2 gigs. So it should be double. Yeah, it's exactly double. See, F32 is exactly double this guy. And I also said I want to do a Q. What's the other one I said? I want to do a Q. It was Q2-K. So I'm gonna call this one Q2-K. Q. Okay. So that one should be really small. That should be a horrible quality, but we'll see. We're doing this. This is a speed test. Okay, so 2 is this one here. Let's see, 1.6 gig. Originally the Q16 was, it doesn't seem to make too much of a difference there. Yeah, very basic difference, but we'll see. Alright, so let's clear this. Now, the first one we're going to run is we're going to time the our control point. So I want to, let's see, which one should we do first? We're going to use the default. We're going to use everything's going to be default. Obviously, I'll show you how you can speed things up, but I'll do that for the fastest one. So what I want to do is I'm going to do the first one will be FP32. This one here, the biggest one. So what we're going to do is okay. I think the best way to do this is to I'm going to do the white shoe one, just so that's a perfect one to test all this stuff out. So I'll paste this one here. Oh, actually, no, I know the perfect thing to do. Just give me a second. We'll do the tests. Oh, do I have them here? No, okay. So let's do the tests here. So this one is going to be white shoe, and this is going to be, what is it, okay, this was F, this will be FP16 001. Okay, and oops, I forgot to put time. I'll call it test. Okay, so I'm gonna, it's PNG, looks like it's PNG as well, so that's fine, PNG. Okay, paste this guy in here, zoom in. So the time is just so you can see the system time, just in case. You know what, let's also open up a clock here, so we can also time it. So I'll put this always on top, so we can see what's going on as well. Alright, so I'm going to press enter here. Oh, of course. Is it done? Oh, permission denied. What the? Okay, I guess that's good. What did I do wrong here? Did I spell it wrong or something? Permission denied. Oh, duh. I forgot to put bin/sd. . Let's clear that again. But what is going on here? What did I do wrong? Unknown argument. Oh man, what is wrong with me? -m. Jeez. Okay, finally. Jeez. That is slow. What is going on here? Did I press enter? Oh, that was slow. Wow, that was slow. It's using the GPU, I can tell, because I can hear. It's definitely, oh, that is really slow. It's using the GPU, and I can tell because, yeah, you see the temperature went up. So that was really, really, really slow. I didn't expect that. Anyways, so we don't need this. You can tell the time is pretty much good. So I'll leave this one here so you can see what's going on. All right. So I'm going to use the user time. No, okay. It says here it took 12.5 seconds, right? So I'm going to take this time and the user time, just to be fair. Okay, so it says this was 12.15 seconds, and then the user time was 22.311 seconds. Okay, so you can pick whatever one you wanted. So is it 12 seconds or is it 22? To me, I'm going to use the user time here because that's more accurate. In that, I don't know, when it said generated seconds, I guess it minus some of this stuff. For example, see the part that takes the longest is this one here when it's generating the latent images. So this is why something like Mi open will speed this part up, and then you'll be able to get much faster. But I'm saying 10 seconds is, or 12 seconds is perfectly fine. So this model was the FP16. That's a floating point 16. And as you can see, the temperature of the GPU just went down, which is fine. So let's clear this. Next we're going to do the FP32. So I expect that one to be slower. So I'm going to copy this, copy that. And there, and this one is going to be FP32. So paste that one, and you can see I'm using the FP32. That's the one we just created a few seconds ago, GGUF. So this one should not be optimized. It should actually be slower. So I pressed enter, and when you see this temperature going up, that's when you know it's using the GPU. Taking a sip of water right now. You see it's using the GPU there. And you notice I haven't turned on the fan, so it can monitor the temperature. It won't go above 60 too much, and so yeah, see, it's done. So you see it took 12 again, you see this part here, the latent images, that's the part that slows things down. If you could speed this up, Mi open does that, then this thing will drop significantly. I see the temperature is dropping now. That's why I said, like, I don't need to turn on the fan, but just in case some weird stuff happens, I'll be ready to do that. So this one took 12.22 seconds, and then the user one was 24.525 seconds. Okay, so not too much of a difference really. So next we're going to try this one, the first Q8. So this one should be the fastest according to, if you remember, went the AMD website, because this one is only integers, and it's a 512 by 512, which is a perfect integer. So that one should be blazing fast. So let's go test that one. Okay, so that one I'm gonna call it. We'll take a look. So that one is gonna be Q8. I'll just call it Q. Is Q8 underscore 0. That's good enough. And then here I'm gonna copy this one here. Copy. Don't worry about this. This is just a comment. This is where I'm putting the time on the what do you call it? The user time. So as you can see here, when I read this up here, so you see, it always looks for CUDA stuff, although it's no, and then you see it, CUDA in it, it found one ROCm devices. So, and then obviously the device 0, the GFX 906. Again, it loaded the model. You see the Q8. And another way to tell if your GPU supports them, you can see my GPU clearly supports F16, that's floating point. It also supports Q8. And as you can see, the RAM usage and etc. here. And I said, you see the part that takes the longest is always this one, latent images completed. That's the one that takes the longest part. It's 20 steps, but it's pretty fast. You see the GPU also temperature went up. And this one, wow, much a surprise. In this particular case, it's actually 1280. So this is actually the slowest. I don't know why that is. This should have been the fastest, but hey, those are the results. So I'm gonna report them as I see them. 80, and this is 23. 23. It could also be because of the CPU. The CPU is being used for what do you call this? The CPU is being used for like OBS might be hogging the CPU when it's needed for this part. So so there we go. Now I'm gonna jump to Q4. Q4 should be probably a little bit faster than the FP32 and FP16. It might be slower than the Q8, but I don't. It will depend on some how, I guess. As I said, the biggest problem is this one here. So you see, this one, you see the latent image is complete. This is actually longer than the Q32 and the Q16. So had this been, like I said, if I was using MI open, this would have been much faster, and then this image would have been generated even faster. Okay, so let me copy this. Now we're going to test this one, the Q4. There's also a Q3, so we'll check the quality of the images after this. So next one is this one here, and this is going to be a Q4. Okay, Q4K. Clear this, paste this in here. I don't know why it's taking so long. Unless usually it's much faster than this. I don't know what's going on. Oh, this is really slow. Wow, this part is really slow. Yeah, wow, this is slow. It's a little faster, 10.4. So this one, wow, this is the fastest, 12 point. So that's the fastest so far. Yeah, this is the fastest so far. But we'll check the quality. So this is 12.07. Okay. 07. Oops. 107, and this one 22. Okay, so this is the fastest so far. And then this one Q2. Q2K, Q2K. So I haven't turned on the fan yet, so oh, that's slow. Wow. So I said that's the part that's slow. That's the slowest part right there. So this one was 13. I think this is the slowest. 13.8. Yeah, this one is definitely the slowest. 13.82. But obviously, it's not just about speed. It's also how big the models are. So if you have limited RAM or limited VRAM, obviously one of these quantized models can be good for you. 642. All right. Okay. So the winner was Q4. Q4 was the winner. So I'll show you the results. So basically, actually, you know what? Let me copy this into no matter, just so I don't make a mistake. So I'll show you which one was the how I generate these images. So what I did. So as you can see from this result, Q4, this one here, was the winner at 12.07 seconds, and the user time was 22.018 seconds. And then after that one, the F16, FP16 was the second fastest, 12.15 seconds. And then after that one, we had we had this one, the F32, and that's 12.22 seconds. After that, we had the Q8, and then after that, we had the Q2. So let's go check all of them out and see the actual results. So all of them had a shoe underscore white test underscore test. So that's in the S's. Where is the S? Oh, that's O, sorry. Yeah, so it should be around. Oh, that's weird. Shoe underscore white. Oh, E. Yeah, here we go. So these are the tests, shoe white tests. So the first one is this one, the FP32. So let's compare. This FP32. This one should be the most accurate to what the prompt was, and so meaning that the quality is expected to be the best at FP32. You can even get FP64, which I don't think this Q. Does my CPU support it? I can't remember. Did it support FP64? I can't remember. I guess no. I guess it did not. I only chose the one that stable diffusion support. So this is FP16 next. You guys might remember this from some tutorials I did. So again, not bad at all. They're both white shoes, not bad at all. Alright, so then we went to Q8. So this is Q8 here. Right? I can't really tell any other facts. That's because images have some, what do you call it? They're based on pixels. So again, I don't see an issue with this one. Q8, I'm perfectly fine with that one. And then we have the Q4. You notice the difference between all of these and then Q4. At Q4, it does not, you see, it doesn't have a person's legs. It just has the shoes, which is perfectly fine. So if in theory, or not in theory, in fact, that's exactly really what I was hoping to get. And so I don't know why the other ones decided to add more details. That's probably why they were so slow. So yeah, so this one here, so you can zoom in. So when you zoom in, you can obviously see these are pixels. So I think all of them will have that. So let's actually zoom into this one. Yeah, they all have pixels, but you see this one is way more smoother. For example, this one should even be better. Yeah, you can see way smoother. This is just the default one. Yeah, so there you go. This one, you see when I blew it up, you can already see, I wish you could tell me the percent blown up. You can see, you see the difference when you zoom in. Oh, 1, 2. You can see there's already some artifacts there, right? So 1, 2. You see it still looks pretty good. There's a little bit, but I'm saying it's not, it's just smoothly around it. So so just the quality, and obviously 1, 2, you know, this is just the usual smoothing. It's just better, like a little better quality. Now let's check out Q2. What the? Is there even a shoe there? Is this supposed to be a shoe? It's more like a blanket. Oh man, the quality is really bad. Is that supposed to be a shoe? I'm confused. This looks more like a blanket. That's a Q2. That's a Q2. So that's why you shouldn't use Q2, right? Or Q3. So just stick to Q4 and up. So if you want something quick, obviously this will suffice for Q4. Even when you're downloading models, if you can, stick to the Q4s, the final. I said you can use stable-diffusion to convert them into GGUF. So I also did it for video, as I showed you, and I was able to get some decent videos as well with 20 steps. Now, which one was the fastest? This one was the fastest, right? So this one was the fastest. So I'm going to run all of them again, but I'm going to use a different, I'm going to use, obviously, I'm going to add some options, such as, I'm going to add some options such as, I'm going to change the sampler, and I'm going to change the scheduler. And I think I can also, you can also change the number of steps, but I'm just going to, excuse me, I'm going to use the I think I'm going to use the default. I just want to show you how you can get a little bit faster and possibly without a loss of quality as well, just by changing the sampler and the scheduler. Okay, so if I remember correctly, I hope I left it somewhere here. Did I? Yes, so I'm going to use DMP++ 2M. I found that to be much faster, and I'm going to use, that's going to be the sampling method. Is that the only thing I did here? I'm also going to put some diffusion. Would I use diffusion here? Oh, I didn't even use diffusion. Diffusion, the diffusion file is an option where it will actually go, even if you go, to use less RAM, so it will be faster. I don't know why I didn't use that one. Should have used that one. Okay, I didn't use it, but I'm going to do it now. Okay, so all I need to do is take the same guys and just add the diffusion far and the sampling method, and I'll do that right now. I just need to duplicate this, guys. Let me see, there's something else I did. Oh, okay. Yeah, okay. So I'm just going to add, I'm going to show you the same thing with the diffusion. And then after that, I'll add the diffusion, and then I'll change the sampling. So let's just do the diffusion. You should see a speed difference. So I'm going to leave this here. so that we can just compare, so you guys can compare. So what we're going to do now is we're going to add diffusion, just diffusion 5. That's all we're going to add. Copy this, go to here, and put a space here so we can rerun this again, all of them. Anywhere there. Oh, does that make this bigger? 1, 2, 3, 4, 5. Wait, how many did I run? Oh, there were 5. Okay, sorry, I forgot. Yeah, there were 5. That's why I was getting confused. There were 5 of them. Okay. So all I need to do is just add an option called diffusion 5. Just a second. I'm going to add that right now. And again, we're going to base it on the, so just, you can append it just at the end. It's fine. There's no so the first one we're going to start is the F32. So let's get rid of this, and then we'll compare each to each. We just compare the three images later on when we finish. So here we go. This is so FP32. I'll call this one 2. Okay, so this one is the one with just diffusion far here. So this one was 12 seconds before, so let's see how fast this one is going to be. We'll see. As I said, you can change the number of steps. You don't need 8 steps, honestly, but I'll just leave it. Where it is. So you can see there's a speed improvement. It went from 12.22 to 11.50, 11 seconds, and the user one was 23.910. Okay, next I'm going to do the same thing for the FP16 model, and I'll just put it there, and I would say this one is also 2. Let me clear this. Just want to be sure the temperature doesn't go too high. So you see, like probably 8 steps is enough, and then that would speed this part up. I said you can also use MI open, so you already know what algorithm to use. It will be much faster. So 60 is perfectly fine. So this one is 11.32. So is there an improvement? Yeah, there was also an improvement as well. 11.32 and 21.138. Okay, and then two. Okay, so who's next? This one is FP16, so we now have to do Q8. So all I did was just add hyphen diffusion FA. And then, oh, you guys can actually probably see the results here. You can compare them. You can see there is no, well, we'll take a look at this one when they're done. So for Q8, oh, 12.09. much better, but not fast yet. It's not the fastest one yet. 259. Okay, then I'm going to clear this one. I'm going to run the Q4. You guys can see the difference in speed. What is it taking for? Come on. So this generating step is the slowest. So Vulkan is actually faster there. So which was a way we could use both. We'll just be flying here in a second. So this one is 1134. 11.34 and 21.236. Okay, here. Now this test is not scientific, but still, for when you're generating stuff, you obviously want the best quality and decent quality at least, and you want speed as well. So here we go. You can see when it says VRAM, that's a good news, and you can see the temperature. Oh, 65. Oh, I have to pay attention there. I didn't realize it is up to 60 something there, but it will go down. So this one, 13.05 seconds. And it is 23.585. Okay. So I'm going to put this here so we can compare, which I'm actually going to start splitting these guys up so we can see. Okay, there we go, I think. Yeah, okay, so we can compare to each other. So when I added the far, you can see it dropped pretty good. And then the one that was the fastest before is still the fastest, the FP16. You see it went to 11.32, that's still the fastest. The Q8 also dropped from 80, it dropped almost 71 milliseconds, so that's one of the biggest drops, I believe. Actually, this one is also pretty big, that's the biggest drop. And then the Q4, it dropped half-ish of a millisecond. And then the Q2, which you shouldn't use, that dropped was about 80, almost 80 milliseconds as well. So let's check the result for number 2s, all the number 2s. So or compare one to each other. So we have this one here and then this one here. They're the same FP16s, and this one has this are the diffusion far. So they're not bad, no problem at all. No problem at all. So this was this is FP16, sorry about that. I should have done FP32. Okay, FP32, the one that's more accurate. So there we go. Alright, so not bad. I don't see a problem. I don't see any problem with the FP32, 16. So let's go to Q4, compare it to each other with just the far diffusion far. Again, there's no problem at all. Yeah, no problem. They're perfectly fine. And then our Q8. Sorry, I forgot about Q8. Here's Q8. So this is better than, this is the integer one, it's better than the Q4. You can see the quality there, pretty good. And then the worst quality is the Q2. It still hasn't figured out, and I doubt it will figure things out at all. I don't know what it's doing because that doesn't look like a shoe. That is so weird. It doesn't include in yet. Let's just say that doesn't include in yet. Okay. So the final test, I'm going to change the schedule, the sampler from the Euler to what did I say? DMP. What is it? To DMP plus 2M version 2. Now, if in ComfyUI they have something which will show you, it should say underscore GPU. None of those work on. None of those work for me. Now that could probably be because they might work in ROCm 6.3, which is supported, but they didn't work for me with ROCm 6.4. So your mileage might vary. So if you're able to get it, great for you, but for me it didn't work. Okay, so finally we are going to change the sampling method. So what I'm going to do is I'm going to go back there and make a copy of everything again, copy, and just change the sampling method to, yeah, so just append it at the end. You can put it anywhere, but I'll just append at the end just to make this tutorial easier. Alright, again we're going to start with FP32. Jump here. I'm going to put this here, so if you guys want to just see what's going on. Oops, this is wrong. No, this is correct. DPMP plus plus. Yeah, that's the one. Oh, no, that's not. I thought I wanted version 2. Shoot. Oh, it's okay. I'll stay with this one. So, did it go any faster? Actually, it looks like it's actually slower. It actually went slower. So when you have the diffusion file, and this one looks like it's actually slower. Well, when I ran this, there was actually no difference between the times. So maybe it's F32 might be a problem. We'll try the others. So let me write this time down. Oh no! Oh, sorry. It was faster. What am I talking about? It was faster. It's 43. Yeah, it was faster. Sorry. I guess I must have been looking at the wrong thing. 24. Yeah, it was faster, a little bit faster. Okay. Then let me clear this. So in case you don't know what I'm talking about, it's right here. See, I added sampling method dpm plus 2m. That's all I did. And you can see I wasn't even paying attention, but you noticed when it was loading, it was also a little bit faster at 2 iterations per second. Let's clear. Oops, clear. Let's run the FP16 now. So far, FP16 has been the fastest. So let's see if that stays true here as well. And you can see here it says sampling method dpm plus 2m method, and the temperature, as you can see, it's 62, which is perfectly fine. So this one 11, yeah, this one also dropped a little bit, makes a difference. So it's 21. Oh, the user time didn't change. The user time stayed the same. Now we're going to run Q8. This was the fastest for me when I tested this think it was yesterday or 2 days ago or whatever. So this is the Q8 one. Oh shoot, my fault. Okay, that's fine. I didn't realize I'm using the same name. I should have actually changed the. It's gonna override the image. That's fine. It's okay. Okay, this one seemed to have flown a little bit. It did go down, but still not the fastest. It's still in the 12 seconds and 22.228. And what's this one? Now we'll do the Q4. So this is Q4. Okay, Q4, which was the champion and stays the champion so far. 24, oh, 26, and it's 21.27. Oh, this actually went up. Wow, the user time actually went up. And finally, we have the Q2. I don't even know why I bother with the Q2, but just for the test completion. Okay, it looks like, I don't know why it's not pasting. Q2, yeah, Q2, there we go. So as you can see here, you see it says Q2, 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 Q2. Okay, and this one is 13 point. Is this still the slowest? Okay, this one is the slowest. So it has no point because it has to convert everything into 2, 3, 2, 1. Okay. You copy this here. This was actually 2. I overwrote it, so I forgot to change this number here. That was my fault. But let me copy here to FP16. I've changed it so in case I run this test in the future, we'll be able to test them as well properly next time. This is Q8. Alright, so let's take a look at this. So for the FP32, that's floating point 32, this is, I believe, the fastest. Yes, this is the fastest. So if you change the sampling method, I said you can also drop down the number of steps. You see I got it down to 11.43 seconds from the initial, just the default 12.22 seconds. And then for the FP16, that's the default, it started off at 12.15 seconds, which is pretty fast. And you got it down to 11.23 seconds by using this sampling method. Now, as I said before, in the future, if they do allow GPU, there's some, ComfyUI already has them, and if the GPU support them, obviously they'll be even more faster. And I said there's also other options. There's the MI Open. That will also speed this up significantly. You can get this down, as you saw in the screenshot. I was able to get them down to something like 6 seconds. And the scary part is you can even go. I remember when I was running ComfyUI, by the way, I was able to do images, even doing a live stream with the GPU recording as well. I was able to get something like 4 seconds. Now off screen, meaning that without OBS or anything like that, I was able to get it down to like 2 seconds. So so there's probably some optimizations still to get done. But I just want to show you that if you use GGUF, you're able to get significant savings as well. For example, here you see this one is a Q8, 12.80, and you see it dropped a lot to 12.09 when I added this diffusion far, and then when I changed the sampling method, I still got down further to 12.03 seconds. And then of course when it comes to Q4, it started at 12.07, not bad, and then finally got it down to 13.434, and then finally 11.26. I believe this is the fastest. Oh no, it's not. No, it's not. FP16 actually won. Yeah, so obviously we'll check the result to see if which one is better. And then of course the Q2, I don't think I need to say anything about this one. It's the slowest in all of them. So, and the results were very inaccurate. That's expected. So don't even bother with this one. Not even for testing. It's not worth it. You're better off, even if you just use your CPU, you're better off just using one of the other models. Just wait a little bit longer. So now let me get this out of here. So as you can see, let's check the results. So let's compare. This was the original one, just the default Euler, and of course this is, oops, that's the wrong one. Oh, it is the one. Look at that. Look at that. Boom! By using a different sampler, you get exactly this, and it's the same thing. You see 0, 1, 0, 2. So I said when you add some options, you can get, obviously what I wanted is a shoe. So this is great. That's it. So it's the same one, FP16, FP16. And then let's check the FP32. So you see by changing the sampler, it actually came out the way we want, and you can see it's very similar to the what do you call it, the FP16 as well. So I remember FP16 was the fastest, so you don't always need the highest. Oh, I forgot to do a test here. Give me a second. I forgot to do a zoom test. Not bad. That's FP16. I expect FP32 to be even better. Yeah, it is. There we go. But I'm saying is nobody's gonna zoom in that much. And this one, look how horrible this one came in. You don't even see a shoe. I still don't see a shoe. What is this? Are these supposed to be shoes? Yeah, so it's way off. I don't know what it's doing. It's on its own little. So Q4 is not bad. Also, was Q4 the fastest? I can't remember now. Well, Q4 was the fastest until the last part when I changed the sampling method. Then it became the second fastest because Q16 actually won. Now, when it comes to video, it's a whole different story. Obviously, you want to use only Q4 because especially if you have memory issues. So this, you can see, not bad at all. Not bad at all. And of course, and then the Q8 here as well. Q8 is also not bad. That's just pure. There's no floating point. Not bad. Not bad at all. More consistent results as well. So that's it. That's what I want to show you, the results. That if you make some tweaks, you're able to get so slightly different results and slightly fast. And I said I can still get this fast if I enable what did I say, the mi open. So let me show you my batch RC file. I'm just going to cut it. Let me clear this. I'm just going to output it onto the screen. So just say cut bash RC. And here's the thing we care about here. So you can see here I have the override HSA underscore override underscore GFX underscore version 9.0.6. This one is commented out, but you can see here. And this one, you might, if you guys remember, this one devices equals 1, that was for the distro box. I'm not using that anymore. Hip underscore visible device is set to 0. CUDA visible device you have set to 0. Yes, you have to do that. If you don't do this, it won't work. Like, it won't discover your. If you notice all the Python stuff, everything, it always looks for CUDA, even though it's not CUDA. So just make sure you add that. And this is what I had before for MI open, and I set it to 3. So I put some comments here. 0 is the default. 1 is always default. 2 to 4, that means it will force search it. So I said 4 will always do a forced search, which is be slow. 3 means that if it finds the fastest algorithm from last time, it will use that one. Otherwise, it will then do a new search. So I said that's why I set it to 3 here. And then the path. This is obviously an SSD. I only have one drive that's on an SSD, but I'm saying it looks like either it's not fast enough, or there's a problem with there's a bug. So that's why I commented them out. So what I'm hoping for is one of two things happen. Actually, one of three things happen. Memory prices drop, then I can add more memory, even though I don't want to buy more DDR4. What I really like to do is buy an NVMe drive, so it's going to be much faster than these SSDs, and that might resolve the issue. Or another option is they fix the bug, and yeah, I can continue as is for a while. And then this one here, the PyTorch underscore ROCm underscore arch. I don't know what this one was for. I think this one was when I was trying to install maybe SD.next. I think that's what I want. SD.next wants to install another version of ROCm, and yeah, so I said no, no, thank you. So it also doesn't support Python 3.14 at the time of this recording. So I was like, okay, no, I'll stick to ComfyUI. Yeah, so there we go. I want to show you guys one more trick before I let you guys go. So in ComfyUI, you can print out all the just to show you the difference. So for example, if let me clear this. If I type bin /sd-help, and the part I'm looking for is right here. Not this weight. You see, these are the weights it supports, anywhere from F32, excuse me, to Q5s, Q8s, etc., etc. So image gen, video gen, upscale, etc. What am I looking for? Oh, this samplers, samplers and schedulers. Let's see, where are they? Okay, man, I'm going too fast. I'm gonna have to zoom out. Oh, schedulers right here. And where's samplers? Oh, sampling method. Okay, sampling method. Let me zoom in here. Okay, so the sampling method, you see, it's much less than the one that comes with ComfyUI. That's why I said I can test on ComfyUI and see which ones are good. So for example, there's this one here which I didn't use. I don't know why. I should have used version 2. I'm guessing that's probably going to be a little bit faster than this one. And see, these are the ones. I think the default uses Euler _A. So that's not too bad. And then you see there's all these ones, 2S, blah, 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 all this stuff. So it's much less than ComfyUI, and I'll prove that to you in a second. And then the schedulers, you see, you have discrete, crass, exponential, IS, git, smooth step. This one is really good for images, SGM _uniform, and simple. That's it. Now the trick I want to show you is if you go to I'll go back to ComfyUI, open up the source here, the environment, and activate it. I don't need to start ComfyUI. You can always do this even if ComfyUI is running. You can just start up another instance. I don't need to start up ComfyUI. So what you can do is you can find out what you can output all the what do you call them? You can output all the schedulers. Now to do that, let me grab the code. Yeah, so I'm going to show you all the samplers first. I'll show you the samplers, just simple Python. Paste it here. And just wait a few seconds. Let me zoom out just a little bit. It should print them out. Why is it so slow? Jeez. Well, I don't know why it's slow. It's usually much faster than this. You gonna work? Wow, that is slow. That is slow. Is OBS really that much of a resource hog? That is super slow. As you can see, way more, right? So the ones I was telling you about, you see the ones that say GPU. See, like this one, GPU. I was not able to try them out in ROCm 6.4, but if you guys are able to run those, I think those will give you a significant, especially when you're running stuff like video, give you a significant boost as well. So you can see way more samplers than the, for example, you see DMP_fast. I don't have that one. This one, the CFG_PP, I don't have that one as well. So even the Euler ones, you see this one is Euler, I guess the Euler_A must be ancestral. You see there's ancestral_RF, ancestral, you see there's way more. ROCm, LMS, way more. And it's the same thing with the what's the other one? The schedulers as well. I think the schedulers are fewer, but they're still more than what I have. And there's also seeds, SA_solver. Some of them might maybe be old, maybe for historical reasons, but still it's way more. Obviously, the older they are, they're probably been battle tested. So you see here, you see this is simple. SG_uniform, I believe I have that one. Keras, exponential, DDIM_uniform. I don't have a beta, I don't have that one. Normal, linear, quadratic, and KL_optimal, right? So you see, and simple. So I think I do have simple, this one. Obviously, it's an open source project and it's still young. So if we go back here, where here's the sampling methods. You can see very few, not as many. And then Euler_A, that's the ancestral one. And then we see when we go to the sampler, the scheduler is up here. You see there's only discrete, Keras, exponential. Actually, there seem to be almost all of them there, so that's great news. All right, and then from other tricks as well, there's something like you can VA_tile. You can set the tile size if you wish, and then you can also do what do you call it? There's an option here. Oh yeah, VA on CPU. That's another one to save some memory. And this is the one I was telling you about, using diffusion_FA. That's the flash attention and diffusion model. So you can enable that as well. All right. So yeah. So those are little things you can do. So there's quite a few. Oh, offload to CPU. This is another one as well. You can use offload to CPU. So weights in RAM to save on VRAM. I don't need to do that. I have more than enough VRAM, especially I have 32 gigs, so I don't need to do that. Yeah, so there we go. And I said before, you can also use it for image generation. That's what we're doing. That's the default. Video generation, upscale, and then convert. As you guys saw, I did convert today, and obviously everything has been image generations. All right, and did I show you guys did we compare the results? Oh yeah, we did. I did remember. Yeah, I did compare them, and I was making fun of this Q2. So Q2 should actually be disappeared right now. Where's Q2? Q2 is useless, so just delete that one. It's useless. Q8 and Q4 is fine for speed wise. So depending on what you done, I said like for this particular model, yeah, I obviously FP floating point 16 is perfectly fine. And I said you can even get faster by using MI open. All right, so with that said, I think we can end this live stream. Well, it's been almost 2 hours. So I don't need this. I can just close this, and I can just Control C. That's it. You guys might even hear a little whine sound. That's shutting it down here. It's complete shutdown. That's fantastic. So I'll leave you guys with the. This is not needed. Neither is this. Just exit here. And I can exit this one as well. Oh, I should actually, it doesn't matter. I don't need to deactivate it. It's perfectly fine. So yeah, so in the build here, you can see these are the images that we did generate today, and they're perfectly fine. So, okay. So let's finish this up. If I have some additional resources, if you're looking to expand your programming skills, I offer a couple of great resources. I have Learning Python book. It's available on Amazon. The link is also in the description. It's a beginner-friendly guide to learning Python. I also have a course. It's called Learning Python. It's available on jamboshop.com. It's a detailed course that covers Python basics and intermediate topics. The link is also in the description. I also offer one-on-one Python tutorials. If you need personalized help with Python programming, feel free to reach out for one-on-one online tutorials at ojambo.com/contact. The link is also in the description. And if you need assistance with ROCm, or want to migrate your setup, you can contact me at ojamboservices.com/contact. I hope this guide and this tutorial helps you with your ComfyUI setup running Linux with AMD Instinct Mi60. Let me know if you have any questions or run into any issues. With that, I want to implore you guys again that you should subscribe, like, follow, and leave comments, because that helps this channel. As I said before, the more viewers that get this content, the more that they can share information. And I understand all this stuff now, and I'm sharing with you guys. Hopefully I did a pretty good job, because I said I had to learn this my way, and because the people who tried to help me in the past, they had like NVIDIA stuff, and that doesn't quite work, especially on Linux and for AMD. But I did figure it out, so I want to thank all of them as well, and this is why I'm sharing with you guys. So and then I also have some other recommended resources. Thanks to you, Elijah Joel, as well, 5338. Thank you very much. I also have some other resources where you can help out the channel. For example, I live in a cabin in a rural area, and there's no internet here. There's no cellular service is sporadic. So I use SpaceX Starlink residential service. This is my referral link. So if you use my referral link and get the service, I'll get 1 month free, and you'll get a discount. So the discount depends on your geographical location, but you will get a discount. So for example, in Canada, right now you get the equipment for free, and that's a significant savings. So if you're in another place in the world, you might get a different discount. I don't know what it is, but you definitely get a big discount. So do use my referral link if you're thinking of getting SpaceX Starlink residential service. The next one is an affiliate link. It's my this little guy. It's the Honeywell HeatBud personal ceramic heater. It's available on Amazon. It has, you can see the switch here, off, low, and high, and then it has a trip protection, meaning that if it trips over, it will trip that and it will turn off. So low uses 170 watts, high uses 250 watts. So it's very, very efficient. I use this to save over $100 a month in propane costs. Propane is what's used to heat the furnace for this entire house. So my first year here in the mild winter, I was paying $350 a month in propane, which is preposterous. Last winter, harsh winter, the coldest month, February, I paid $250. So meaning that I saved $100, probably even more if you actually think about it. It's because of this guy. So what I did was when I started using this, I set the temperature to 16 degrees Celsius, and then I would, in my workspace, for example, right here, I use this guy, and when I need it, like a few times an hour. I just switch it on for a few minutes, and that was enough for me. Obviously, just warmly is also important. So usually I rarely use high. The only time I use high is if I accidentally click it. I usually use low, and it's fine. So basically, what this little guy will do, it might add, if I left it on high for maybe 10 hours the entire day, which is impossible, I could probably pay maybe an extra $5 a month on my electrical bill, which is way better than paying $200-300 extra a month on propane. So this little guy helped me out. So that's my affiliate link. What that means that if you do purchase this and use my affiliate link, I'll get a commission on the sale. So if you're thinking of getting a space heater, I highly recommend this little guy. And I said with it's able to run off. The reason I also got it is because it's able to run off solar, right? Because it's only 250 watts at the high and 170. So I did buy 200 watt panels last year, and obviously I got some batteries. I didn't have a chance to set them up. I'm hoping to do that this year because the shed is finally done, so I can now focus on doing other projects. And the other one I have is my novelette. It's called The Algorithmic Serpent. It's created by me. You see my name there, Edward Ojambo. It's about a scientist who creates an AI system and loses his mind, so he has to regain control of his mind and the AI system. This is the back. This is a psychological thriller. I'll open up so you can see the pages. Oops, there we go. We'll do it again. You see the pages in there. There's also an ebook version. The ebook version is available for free if you have Kindle Unlimited. So if you have the means, please pick it up and let me know what you think. So I made it as affordable as possible. It's mostly at cost. Obviously, for this paperback version, it's for printing and shipping, and for the ebook version, it's for storage costs. All right. Anything else? Yeah. So if you want to know more about me, you go to ojambo.com, pick any article, and then you can scroll down. You can read my bio. I'm a software engineer or freelance programmer. And then I have a link here to all my bookstore on Amazon. It has programming books. Obviously, this is my first non-programming book. That's why I want feedback from you guys. And I also, if you need any support, I have ojamboservices.com. That's my primary business. That's how I make a living. And then I also have courses at ojamboshop.com. If you want a coupon, let me know. I used to print a lot of coupons last year. I haven't had time to do that this year, but if you guys request them, I can do that. All right, and then if you some people requested, they want to know how to reach me. So there's several ways to reach me. As you can see, if the article is new, you can always leave a comment at the bottom of each article, and you can also find me at these channels: Odyssey, Rumble, BitChute, and YouTube. You can post something in the comments. I'll get it and I can reply. So, but the best way to contact me is right here, the contact page, ojambo.com/contact. That's the fastest way to reach me, because all the other ways, except obviously this contact form, this comment form, is that they go through third parties. So this is the fastest way to contact me, where to actually come to me.